you're still plugged in.
Okay, so today
Evan, you ready?
we're kind of switching gears a little bit. We are going to do graphing linear inequalities. We're getting away from systems for a day. We will come back to systems on the next one, but you need to practice this one before we can do the next one. So what we're doing today is linear inequalities, not linear equations. It will not be equal signs. They will have inequalities. Okay. So a linear inequality. That's an inequality instead of an equal sign. By the way, if you have a highlighter handy, it's a nice thing to have for today. If you don't, not a big deal.
And the pencil is much easier.
Yes, pencil is much easier. Okay. Now, the solution for linear inequality, and when we do this, is an ordered pair that makes an inequality true. A point that's in the shaded region, what we're going to have is when you have a linear equation, you have a straight line. When you have a linear inequality, you have a line and you have a shaded area too. Okay, so what we're going to be doing is graphing linear equalities. Instead of y equals, for example, instead of y equals 2x minus 4, it's going to be y is greater than 2x minus 4. Almost exactly the same thing. Now, there are a few properties we need to talk about here. If I have y is greater than, I have a dashed line. And I shade the larger values, I shade above, because y is greater than that. So my line, instead of being a solid line, I have a dashed line. And my shading is above the above the line I graphed and not below the line I graphed. And you'll kind of see what I'm talking about a little bit when we get to it. When I have y is less than, it is still a dashed line. Okay, it's a dashed line. The reason it's a dashed line is because it's not or equal to. Y is greater than those values, not equal to those values. Those things on the line are not actually part of my answer. Okay, they're not actually part of my answer. If I have y is greater than or equal to, and this is where it gets important what you're paying attention to. I do have a solid line because it's or equal to, y can be those values. And then the last one is going to be y is less than, it's a solid line shaded below. Okay, now here's what you want to remember when you're doing this. Okay, when we graphed inequalities before, if you had less than or greater than, that meant you had an open circle because it did not include that point, right? Well, when we're doing linear equalities, we have a dashed line because it does not include those points on the line. It's the same idea. An open circle, that point was not actually part of my answer, right up to it. Dashed line is the same thing. If I had less than or equal to or greater than or equal to, I had a solid filled in circle. I have a solid filled in line. Same idea. If it was an open circle, it's going to be a dashed line. If it would have been a closed circle, it would be a solid line. Okay? So let's do a couple of examples, do the ones that are on here. Okay? So I have y is greater than 2x minus 4. So I graph the line the same way I would have graphed the line if it was equal to. I still do my graphing the same way. I look for my slope, and I look for my y-intercept. What's my slope on this one? How many x's do I have? 2. So my slope is 2. We'll make it 2 over 1. What's my y-intercept? 4. Actually, it's negative 4. Okay. Now, before I graph it, I have a very important decision to make. Is this graph a solid line or a dashed line? It's a dashed line. I have to remember that before I graph because I don't want to be erasing things. So I know I have a dashed line on this one. So when I graph my line, and you guys have rulers, you should not be doing it freehand like I am. I still do the same thing. I go down to negative 4, make a dot. And then my slope is 2 over 1, so I go up 2 and over 1, up 2 and over 1, up 2 and over 1. And I have a dashed line that goes through there. It's not a solid line, because those points aren't actually included in it. Okay. Now, I'm not done. Because here's the important part. Here's the really new thing that we have that's different. Is that I have a whole range of answers. Normally, with an equation, I have just the line. This one I have not just the line, and obviously the line itself is not part of the answer. I have half of that grid is part of my answer. So I need to shade one side or the other. Now, if it's y is greater than, just like this, I can use one of these. Y is greater than, it's dashed, and it's shaded above, which means that I'm going to shade everything above. Any point that is in the shaded area is a solution. Any point that's in this non-shaded area is not a solution. It's as easy as that. Shaded area, all my possible answers. Unshaded area, not my answers. Okay? Questions so far? If you can graph lines, this isn't that hard. Okay? And this is one of the ones where I said if you have a highlighter, this works really good. Use the highlighter to shade. And if you don't have a highlighter, just shade with your pencil or something. Just do what I did. It's fine. Okay? But I like I said, if I do this on test answer keys and stuff, I use highlighters when I do it generally. Okay. Let's do the same thing on the next one. First step, identify my slope and my y-intercept. What's my slope on this line? How many x's do I have? Negative 3 over 4. What is my y-intercept? 4. Okay. Now, the all-important question before I graph, solid or dashed? Solid line. Going back to the 70s, solid. So I got a solid line. Everything is less than. So I need to know when I graph it, I've got a solid line. That makes it really easy. I graph this just like I would a normal line. I go to 4. My slope is negative 3 over 4, so I go down 3. 1, 2, 3 over 4. 1, 2, 3, 4. And I can't really go down 3 and over 4 again. And I can't do it the other way. So these are my lines. And like I said, this one's a solid line. Now, do I shade above the line or below the line? Yeah, y is less than, so I shade everything below the line. which means everything in there is shaded. Not that bad, right? Questions? Okay. Second side. Okay, you have some homework problems that are just like this. Okay, you have the inequality and you want to know, is this ordered pair part of the solution? And this is the same way as if it were an equal sign. Do these numbers work in the problem? So I take this x and this y and I put them in here. So y is 2. So 2 greater than x is 1. 1 minus 3. And I simplify it and see if it's a true statement or not. 2 greater than, what's 1 minus 3? Negative 2. Is 2 greater than negative 2? Yeah, so this one is. Yes, it is. That's it. Plug the two numbers in for x and y, see if it's a true statement or not. Okay. Second verse, same as the first. Plug in x and y. Negative 3 for x, negative 7 for y. So I have negative 7 greater than negative 3 minus 3. What is negative 3 minus 3? Negative 6. So I have negative 7 greater than negative 6. Is negative 7 greater than negative 6? No, it's actually smaller. So this one is no. No bueno. Doesn't work. Easy peasy, right? And you do have a handful of these problems on your classwork, exactly like that. They give you an equation, they give you a point, put the point in, doesn't work or not. Okay. Okay. So let's do some graphing again. Once you set up this one first, identify your slope and your y-intercept. Y equals mx plus b. What is the slope on this one? What's m? 1 over 1. That's 1. How many x do I have? I have 1x. And what do? I make it a fraction, 1 over 1. What's my y-intercept? What's my b? Negative 2. Okay. Do I have a solid or dashed line? Dashed line, because it's not or equal to. So I have an inequality. I have a dashed line. It's important to know that before you graph it. So you graph it. Go to negative 2. And then I go over 1 and up 1. Over 1 and up 1, over 1 and up 1. And I do the same thing in the other direction. And I have myself a nice little dashed line. Now you'll notice in your notes what I have on the board. Testing points for shading. Because I frankly do not remember whether I'm supposed to shade above or below. I don't remember what we had on the previous page. I never do. I don't care. And it doesn't always work anyways. It only works if you have y by itself, whether you're, ooh, it's greater than I shade above, it's less than I shade below. And what if it's at this really funky angle? Sometimes it's hard to tell. So this is what I do, and this is what you have to do when you have it in standard form, which we're going to be doing here, an example of that in a minute, and what you're going to have to do on a lot of your classwork. You have to pick a point and test it to see if it works or not. So what you do is you choose any point that is not on your line. Now there is one point I choose every time that I can, because it's the easiest one to do. The absolute easiest point to pick to test is the origin, 0, 0. 0 for X and 0 for Y. Those are the easiest ones to pick. So that's what you do. You want to test a point. So I'm going to test the point 0, 0. And what you do is you take those 2 points and plug them into the equation that I just scrolled off the screen. There we go. Plug in 0 for Y and 0 for X. 0 greater than 0 minus 2. Is 0 greater than negative 2? Yeah. So my test point is true, which means that my test point is in my shaded area. So where's the test point? It's here. It's on this side of the line. I shade the side of the line that includes my test points. Does that make sense? If it came up false, what would I have done? I would have shaded the other side of the line, the side that does not include my test point. Okay. Questions so far? Okay. Uno más. So I want to graph this one. This one's in standard form. I have options. I can rearrange it. I don't want to rearrange it. 5 goes into 10. 2 goes into 10. I'm using X and Y intercept. Cover up my X's. And I have negative 2Y equals 10. Divide both sides by negative 2. And I get Y equals negative 5. So I have negative 5 on my Y. And then I do the same thing with my X's. Cover up the negative 2. I get 5x equals 10. Don't worry about the inequality when you're finding the points. Okay. Cover up the negative 2y, 5x equals 10. Divide by 5, x equals 2. So I have a point on 2. Solid or dashed? Dashed line. It's not or equal to. I have a dashed line. I have a dashed line. Which side do I shade? The only way to tell with these is to test. Pick a point. Now, I said the origin is the easiest. If the line does not go through the origin, I pick that one every time because it is the easiest. But sometimes the line goes through. It doesn't matter. As long as it's a point that's not on the line. If 0, 0 is not your cup of tea, you don't like the point 0, 0, you prefer the point 1, 2 for whatever reason. Okay, if the line doesn't go through the point 1, 2, then you can put point 1, 2 in there instead. It doesn't matter. Okay, and sometimes the line goes through the origin. You have to pick a different point. But once again, I pick the easiest one whenever I can. Plug in 0 for y and 0 for x. 5 times 0 minus 2 times 0 greater than 10. What's 5 times 0? What's 2 times 0? What's 0 minus 0? So I have 0 greater than 10. Is 0 greater than 10? No, it is not. This is false. So the point that I tested is not a solution. What does that mean? It means I shade the other side. Okay. If it works, you shade the side that has the point. It doesn't work, you shade the side that doesn't have the point. Piece of cake. It's really not that difficult to do. Okay, if you can graph a line, you can graph an inequality. It's just a couple of new things to throw in there. You have to have a dashed line sometimes, a solid line sometimes. You have to know which one's which. And you have to shade one side or the other. Okay. Any questions? Yes, that is a valid question. Yes, you may.
No.